Hi everyone, so far we've talked a lot about determining R and S, stereocenters, asymmetric centers, and kind of danced around looking at relationships between compounds, okay? It was really important that we first learned how to determine R and S and familiarized ourselves with stereoisomerism, because now it's time to dive into learning the types of isomeric relationships that we have. This video will be an intro video on types of isomers. Isomers are compounds that have the same molecular formula, but they will differ with respect to each other either structurally or stereochemically. It can be one or the other, okay? So there are two kind of umbrella categories for isomers. We have structural/constitutional isomers, and we have stereoisomers. Constitutional isomers differ in the attachment points of their atoms or groups along the carbon-hydrogen framework. We could say that constitutional isomers are built differently. You could actually name them differently, okay? 1,1-dimethyl cyclohexane versus 1,3-dimethyl cyclohexane, for instance. However, stereoisomers, remember stereo means 3D. These are 3D isomers. They differ in the 3D attachment points of their groups at given carbons, meaning stereoisomers will have the same constitution relative to each other, but in 3D space, those groups at the same carbons will differ in 3D space. You could have cis-trans stereoisomers. You can have what we call enantiomers, diastereomers, geometric isomers, okay? And we're going to be talking about each of those types of isomers in the following videos. But remember, isomers are compounds that have the same molecular formula, but they will differ either structurally or stereochemically. Cannot be both.